Hello everyone, this is Professor Krupal Patel from Srimati MP Patel College of Commerce and Center for Professional Courses, Kadi. Today we are going to start with topics of applied statistics in Bcom semester 3 and subject code is Bcom 304. So let's start with the course content. It is a 4 credit course and units are divided into 5 parts. Unit 1 is process control, Unit 2 is product control, Unit 3 is sampling techniques, Unit 4 is transportation problems, Unit 5 is assignment and replacement problems. So let's start with Unit 1, that is process control, or you can say statistical quality control. Now let's start with the introduction. So first of all, what is quality? So quality covers main 3 aspects of the product, like the product should be easily available in the market, the product should be cheap in price, and the product should maintain their satisfaction level. Say for example, Balaji wafers, Parle-G, Dairy Milk, etc. They all maintain their standards, so the customers are satisfied with their products. Right. Proceeding further, what is quality control? So quality control is a procedure or set of procedures intended to ensure that the manufactured products or performed services adheres to a defined set of quality criteria or meets the requirements of clients or customer. In short, take any company, that any X company should maintain their quality standards so that each and every customer gets satisfied. Right. Proceeding further, now what are the causes for variations in quality control? So do we find a similar products of the same company available in the market? Yes, we do find. Say for example, take a 2 bath soaps and check whether their fragrance is different or their price is different or their quantity is different. No, we don't find any change in either in fragrance or in price or in quantity. Why this happens? Because the main reason is that the company is maintaining the variations in quality control. That's why this is happening. Okay. Now proceeding further, what are the two major types of reasons? So variations due to chance cause and variation due to assignable cause. These are the two main reasons. Now what is variations due to chance cause? That is kudrati aafato, right? So natural reasons like fire, flood, earthquake, viral diseases spreading, strikes, etc. And what are the variations due to assignable cause? જે દેખી શકાય તેવી આફતો કઈ એમ તો ડિફરન્સ ઓફ ક્વોલિટી ઇન રો મટીરિયલ, જે આપણે રો મટીરિયલ લાવીએ એનું ડિફરન્સ હોઈ શકે, બરાબર. બીજા જોડેથી આપણે ડીલ કરીએ તો અલગ મળે, કોઈ બીજા પાર્ટીથી આપણે ડીલ કરીએ તો એનું રો મટીરિયલ અલગ હોય. સો દેર ઇઝ અ ડિફરન્સ ઇન રો મટીરિયલ. ડિફરન્સ ઇન ઓપરેશન્સ, સો એક્સપિરિયન્સ વર્સિસ ફ્રેશર. If any experienced person is there on a machine, then he is very good, he has very good hands and he can operate machines very easily. So the product outcome is up to the mark. Whereas where the machine is in fresher's hands, then the product may somewhat suffer. Okay. So what is the now, and third is difference in machine, old machines as well as new machines. But obvious old machines maintenance बहुत होता है, ऐसा कुछ होता है. And last is difference in time, day shifts and night shifts. The person who are working in day shifts are enthusiastic and the persons who are working in night shift are little bit low on energy, right? So but obvious there will be a deflection, or you can say fluctuation in the products. Now what are the control charts? A statistical chart used for controlling manufacturing process is known as control chart. Control chart is a graphical method consisting of 3 different lines, that is central line, upper control limit and lower control limit, right? UCL, CL and LCL. So this is the theoretical basis for control chart. So this is how the charts will be drawn. You have to draw x-axis, y-axis, and with the help of formulas you need to find out values of UCL, CL and LCL that we are going to study further, and you have to plot it on the graph. Okay. Now this is how your chart will look, right? This is just an example. Now proceeding further, what are the types of control charts? So basically control charts is divided into 2 parts, variable charts and attribute charts. And again variable chart is divided into 2 subparts, that is R chart and X bar chart. Whereas attribute chart is divided into P chart, NP chart and C chart. Okay. Now how the producer maintain the quality level, especially by using statistical tool. So by using graphical method this can be done. and charts of quality control are divided into two parts, that is charts of variables and charts of attributes. We already studied further in last slide. We already studied charts of variables is of X bar chart and R chart, and chart of attributes is of P, NP and C chart. Now X bar chart is known as chart of average and R chart is known as chart of range. P chart is for chart of fraction defective, NP chart is of chart of number of defective products, and C chart is chart of per unit defects. Okay. Now what are the charts of variables? That is X bar chart, that is chart of average. So it is taken for quantitative information, or you can say quantitative data. For given samples, average is find out and grand average is find out. That means average ka average. Average of average is called grand average, and to find out the values of CL, UCL and LCL, grand average is very important in X bar chart. Same way for R chart, it is taken from quantitative information. For given sample, range is find out. Range means what? Highest value minus lowest value, that is your range. Now what is quantitative data? So quantitative data is a type of data which values is measured in numbers or units. Say for example 10 Colgates, 20 Balaji wafers, like that means 10, 20, which is countable, that is called quantitative data. Clear? Now limits of charts of average and charts of range. So you can, in another word, you can say formulas to find out CL, UCL and LCL. So CL, UCL and LCL is basically a limits of charts, right? So what is the formula to find out CL for average chart? That is X double bar, and X double bar is find out with the help of sigma X bar upon N. UCL is X double bar plus A2 R bar, and LCL is X double bar minus A2 R bar. So CL, UCL and LCL of average chart is given with this help, with the help of these formulas. Okay. Now CL, UCL and LCL for R chart, that is for range. So CL is given by R bar, that is summation R upon N. UCL is given by D4 R bar and LCL is given by D3 R bar. So with the help of all these formulas, we can easily find out the values of CL, UCL and LCL for R chart as well as X bar chart. Clear? Yes. Now conclusion from average chart and range chart. So if all the points falls between the UCL and LCL, then the process is said to be under control. And if any point is falling above UCL or below LCL, then the process is said to be not under control. Okay. So if we are drawing a graph and if all the points are between UCL and LCL, then the process is said to be under control. And if you are drawing a graph and if any one point or more than one point falls above UCL or falls below LCL, then the process is said not to be under control. So let's see example over here. So in first graph, it is the process is under control. The two red lines are there in first graph. Okay, that upper red lines indicate UCL and lower red lines indicate LCL. So all the points which we have plotted, this is just an example. So all the points which we have plotted between UCL and LCL, so that process is called under control. And in second graph, 2 points are falling above LCL, sorry, above UCL. Okay, 2 points are falling above UCL. So the process is not under control. So here we are completing the theory part of average chart and range chart, and if you have any problem, then you can contact me on this email address. Hello friends. So in last lecture we already studied about the SQC and some part of it. So today we are going to start with chart of attributes, because in last chapter we have already studied about chart of variables, right, for X bar chart and R chart. So today starting with chart of attributes, so that is P chart, NP chart and C chart, that is chart of fraction defective, chart of number of defective items and chart of per unit defects. Right, now what do you mean by P chart? So this chart is constructed for controlling the quality standard in the average fraction defective of the products in a process when the observed sample items are classified into defective and non-defective part. Right. So this chart is basically constructed for controlling the quality standards of particular product of particular company. Right. Same way, the CL, UCL and LCL for P chart can be given by CL is P bar, UCL is P bar plus Z under root of P bar into 1 minus P bar upon N bar, and LCL is given by P bar minus Z under root of P bar into 1 minus P bar upon N bar. right, and Z can be 2 or Z can be 3, but basically we are going to take Z as 3 as 99.7% limits. Okay. Now formula to find out n bar is summation ni upon k, and formula to find out p bar is summation xi upon n. That is, xi means defective items in a samples and n means size of the samples. So sigma can be given by under root of p bar into 1 minus p bar upon n, where n is the size of each sample. I already told you that n is the size of each samples, right. So again let's revise. P chart of control limits can be given as CL, UCL and LCL. CL as p bar, UCL as p bar plus 3 under root p bar into 1 minus p bar upon n bar, and LCL is p bar minus Z under root p bar into 1 minus p bar upon n. As you know, why I am dictating Z as 3, because we are taking 99.7% limits, that's why. Now NP chart. The procedure for plotting the points on the control charts can be simplified if relating to the number of defectives rather than to the fraction or percentage or proportion of the defectives are plotted. Alright. So it is simplified by taking the number instead of percentage or fractions. That we have to use NP chart. Clear? So formulas to find out, or you can say control limits for NP chart is UCL, LCL and CL, and CL is given by NP bar. UCL is NP bar plus 3 under root NP bar into 1 minus P bar, and LCL is NP bar minus 3 under root NP bar into 1 minus P bar. So here maximum is written. Why? Because if your LCL comes in negative, then you have to consider that term as 0, right. Suppose say LCL is minus 1 point something or minus 2, then you have to consider LCL as 0. So that's why it is written as maximum as 0 or greater than 0. Clear? Now uses of P and NP charts. So it is useful to find out the average fraction defective of the lots submitted for inspections during a particular period, to know whether the average fraction defective is maintained as specified. So when some of the points fall above UCL, then the presence of assignable cause is suspected, to obtain control limits for further production, and many characteristics of products can be simultaneously checked by in P and NP charts. Clear? Now conclusion from P and NP chart. So if any point falls between the UCL and LCL, then the process is said to be under control, right. If one or point falls above UCL, then the process is said to be out of control. If value of LCL is negative, then it is considered as 0. I already told you that. If one or more points falls below LCL, the process is out of control, and the fraction defective is less of these samples whose points falls below LCL, and its quality is considered as better. So in P and NP chart, basically if the points is falling below LCL, then that type of production should be maintained, right, because it is of better quality, and the points which falls below LCL are known as low spot. Okay. So now what is the main difference between P chart and NP chart? So P chart is a chart for fraction defective and NP is a chart for number of defectives. P chart can be drawn even if all the samples are not of same size or equal size, and NP chart can be drawn only when the size are same, and the calculation are difficult in P chart, whereas calculation in NP is relatively easily, right. So C chart. This chart is used for control of number of defects per unit, say a price or cloth or paper which may contain more than one defect, right. Say for radio in that we can find out many defects, right. In the inspection unit in this chart will be a single unit of product, and the distribution of the number of defects may be assumed to be a Poisson distribution with mean and variance as same. Okay. Now control charts for C can be given by CL, UCL and LCL. So CL is C bar, and values to find out C bar is summation Ci upon K, right, summation C bar upon K, and UCL is given by C bar plus 3 under root C bar, and LCL can be given by C bar minus 3 under root of C bar. Okay. Now C is defects in the unit in the samples given to us, and unit and K is number of samples taken, right. Uses of C chart. So it can be used for controlling the production process, for the number of defects in radio sets, for the number of faults in pipes of the given length, and many more, right. Now conclusion from C chart. So if all the points in the chart falls between the control limits, that is falls between the UCL and LCL, then the process is said to be under control. And next is, if one or more point falls above UCL, then the process is said to be out of control and the variation is found to be and can be removed. So we have to find out the revised limits in it. So if value of LCL is negative, then it is considered as 0. Okay, it is same as P and NP chart. So in short, in P, NP and C chart, if any point, if you get the value of LCL as negative, then you have to consider it as 0, right? So if one or more points falls below LCL, the process is out of control and the fraction defective is less of those samples whose points falls below LCL, and the quality is considered as good quality or better quality. The points which falls below LCL is considered as low spot. Okay. Now, what is the main difference between variable charts and attribute charts? Variable charts means X bar and R chart, attribute charts means P, NP and C chart. Clear? Now in variable charts, these charts can be used when the quality characteristics is measurable, and these charts can be used when the quality characteristics is not measurable, but when it can be decided whether the product possesses a particular characteristics or not. So variable charts are the main charts for X bar, and R charts are the main charts in variables, P, NP and C are the main charts in attributes. So the theory of normal distribution is used in variable charts and binomial distribution is used in P and NP chart, while as Poisson distribution is used in C chart. So these charts are more sensitive and these charts are less sensitive. Attribute charts is less sensitive, and variable charts are used in destructive testing, whereas attribute charts are not used in destructive testing. So this was the main reasons between main difference between variable and attribute charts. Now theory of runs, most important thing. So in general, we conclude that the process is under control and we shall plot points falls between UCL and CL. Sometimes it happens if respective errors occur in process, the points also falls between the lines. Say for example, the logo of Lux Beauty Soap is printed as LUX Lux. In case it is changed to LAX after packing, then it is different measures and it will show the process is under control. Actual scenario is different in packaging. That is, to identify this problem, theory of runs will help the producer to take proper decision, right? So during the process, if the connective points falls at the same side of CL, then it shows the theory of runs and may conclude that the process is out of control, right? Now following points will help us to define theory of runs. So in process, if 7 consecutive points falls at the same side, that is between CL and UCL or between CL and LCL, right? In process, if of 11 points, if 10 points falls at the same side, in process of 14 points, 12 points fall on the same side. Same way in the process of 20 points, if 16 points falls on the same side, then the theory of runs is applicable. So here we complete our chapter of theory part, and I am very thankful to you that you listened to me carefully. And here, if you have any doubt, you can surely contact me on krupal300587@gmail.com.